Hi everyone, glad that you found it. Let's begin. We've got a lot of good stuff to cover today. Your homework assignment and your exam is on Sunday. So you've got something to study over the long weekend. Homework 6 is just covering present worth analysis, which we already finished during the last class period, and so I expect you could probably get a pretty early start on that. Hopefully you've already solved some of the problems. For the exam, we're going to be in this room for the exam on Sunday. So don't go to the other classroom. We're going to be using Excel for one or more of the problems. I think probably just one of the problems. But please come to this room on Sunday, and you don't need to make an equation sheet. I'll provide the formulas that you need for the exam. Today we're going to be talking about future worth and annual worth analysis, but before we get started on that, and actually this is, there's a mistake on the slides. We're actually doing in-class exercise 14 today. Yeah, in-class exercise 14, which is future worth analysis. Okay, any questions on the announcements before we get into the material? Yes. Yes, it includes today's lecture. Let's review last time. Last time we talked about ways to overcome the problem of what if the cash flow diagrams have different useful lives. And the problem is, if they don't have the same number of years, if they don't cover the same study period, we can't compare them. That's one of the rules of economic analysis, is that the two alternatives have to cover the same study period. So we had the example last time where one of the cash flow diagrams was 6 years and one of the cash flow diagrams was 9 years. And one of the things we did, one of the approaches, was called the least common multiple approach. And that used something known as the repeatability assumption. And the assumption is that you can just repeat the cash flow, and in the case of option A, we repeated it 2 times after the first. In option B, we repeated the cash flow a second time after the first. And then they both ended at 18 years. 18 years was the least common multiple for when we repeated those 2 cash flows. The problem with this approach is that sometimes the assumption isn't valid. Sometimes you can't buy that item for the same amount in the future. And so sometimes people will make adjustments to the amounts in the second or third iteration. But what we did was we just, to illustrate the principle, repeated the cash flow the same amounts the next times around. Another one of the options we looked at was contract services. And in the diagram here, what you can see, it's a little bit hard to notice the colors on this particular projector, but what we did is, since option A only lasted for 6 years, we went into the marketplace and found someone who would lease the equipment for years 7, 8, and 9. And so there's a green arrow pointing downwards. Why is it pointing down? Why do we have this downward arrow for years 7, 8, and 9? It's an outflow, but what does that outflow represent? It's the leasing cost. So we still have the same revenue as we did before. There's still an inflow equal to 5,000, but now there's also an outflow for those last final years because we have to pay the leasing fee. And that was the contract service approach. That's how we made them the same length, which is the main thing we have to do to compare alternatives, is they have to cover the same study period. The last thing we talked about was early termination, where instead of extending the shorter cash flow diagram through leasing, which is what we did in option 2, the other possibility is to end the life of the longer one early. And so the cash flow diagram on option B is showing we don't take the revenue in years 7, 8, and 9. Instead, we sell the item in year 6. We put an ad in the paper and we say we have this equipment, or whatever it is we're selling, a business, equipment, it still has some useful life, and so we take the salvage value prematurely. And so now the cash flow diagram has 6 years, and we can compare it to option A. Any questions about these three choices? Yeah.
When we solve the questions, do we usually specify which method to use, or do we?
Okay, so the question is basically, how do you know which one to do? Well, you know, in a homework problem, it'll probably tell you which approach to use. Maybe that's also the case in an exam. But more importantly, when you're practicing engineers, how do you know which choice to select? Well, in some cases, you can't do the contract services or early termination. We're going to be looking at an example today that has to do with dredging a shipping channel. Let's say if you're working at the Port Authority of Dubai, they have to keep shipping channels open, and there's always sedimentation and erosion that makes it difficult for those shipping channels to stay open, and so they need regular maintenance. So that company, the Port Authority, has to spend money to upgrade the port, and they can't lease they can't get some contract services group to necessarily make that open. So it really depends on the nature of the options that you're comparing. Sometimes things can be leased, other times there's no option but to buy it for yourself. And so how do you know which one to do? It's really a case-by-case basis that you have to use your judgment. Are there other questions? Yes? Uh-huh. So how do you know how much this is going to be? Right. You'd have to make an estimate. If it's the case of two vehicles, for example, if you're comparing Hyundai and a Toyota, and you're making assumptions that maybe the Toyota would last longer than the Hyundai, maybe what you would do is you'd say, I expect that the Toyota would last 9 years and the Hyundai would last 6, and so you'd go into the paper and you'd try and find what's the value of a 6-year-old vehicle. And so you don't know, maybe you'll be told if it's a homework problem, but the important thing is professionally, when you're in the real world, how would you know what that salvage value is? You'd have to look at the market and just make an estimate. Any other questions? That's review. Today we're doing future worth analysis, and it has some of the same rules as present worth analysis. The big rule last time was cash flow diagrams have to have the same length, and that's still our rule, even when we're doing it in terms of the future value instead of the present value. Now, in present value, we took all of the inflows and the outflows to year 0. In future worth analysis, we're going to take the whole cash flow diagram, including inflows and outflows, to some future year. And the reason why we might do that, sometimes there are projects that last for a really long time, and including just the construction phase is a multi-year project. If you think about building a road or a bridge or a very tall high-rise building, those may require years of outflows at the beginning, and in those cases, sometimes it's important for us to know what's the future value, maybe once the construction is completed. You want to take all of the costs during construction to the future so you know how much have you spent so far. That's one example, is when it's a multi-year construction. Another possibility is in projects where you expect there to be a sale of the item before its useful life is concluded. So taking all of the inflows and the outflows to the future, which is the year of sale, will give you a better idea of fair selling price for the item, if you already know how much you've gotten out of an investment. So those are some of the common applications. Let's take a look at one of the applications of future worth analysis here with this dredging example that I've already mentioned. We have two options. This is an example with the Port Authority. They can either completely rebuild a shipping channel, which is option A, and you'll notice from option A, it costs them $220 million each. There's 3 payments of $220 million, starting in year 0. They have to spend the money to start the construction. So they have 3 payments of $220 million, and then starting at the end of year 3, they receive revenue until year 9. So that's the cash flow diagram for option A. Option B represents a more temporary solution. It's periodic dredging. Rather than rebuilding the shipping channel completely, they can just dredge it every 3 years. And so you'll notice it's a different life. we can't compare option A and option B unless we do something, unless we make them the same number of years. All right, we can't terminate option A early. That's not a choice for us because there's no salvage value for a rebuilt shipping channel. We don't think that's something people would go and buy. Likewise, the contract service approach isn't an option for option B to make it longer. So we can't do those two. What's our only other choice for trying to make them the same number of years? LCM, or the repeatability. So when you solve this using Excel, you're going to have to use the repeatability assumption to make both of the cash flow diagrams 9 years, and then take all of the cash flows, take everything to year 9, using the FV function. And let's refresh our memory, what is in the FV function? So the form of the function is equal FV, parentheses, what comes next? Okay, it's going to ask rate. And what do we need to remember when we're doing the rate? Okay, one big important thing is anchor it. And what's the other thing to remember? It says here 7% interest. Right, decimal. Very good. What's the next thing in the future value function? Okay, so it's asking NPER, which means basically how many years. So for example, if we want to take $225 million and we have to take it to year 9, N should be 9 because it's not going 0 years to year 9. It's in year 0, but that money is being moved 9 years. And so the thing for us to remember is that when we do NPER, we make this special column. Right. It is years until year 9 or 11 or however many years it is. What's next after NPER? All right, yeah. The function is looking for PMT. It wants to know what is the recurring payment for however many years N is. But we're not using the FE function that way. So we put in another comma to skip that payment field. And instead we go to the field where it's asking what is the present value. So what do we do?
Negative.
Right, negative, because Excel flips the sign of the FV function and the PV function. It doesn't flip the sign for NPV, but it does flip it for FV and PV. So negative of the amount. We'll say negative amount. Okay, let me mention just a couple of other things. Today at the end of the class, I'm going to ask you to upload your Excel file. So save your work. And if you haven't already created a file name, now is a good time to click save and maybe put it on your U drive, or if you're using a flash drive, whatever you want. It doesn't matter to me. But when we're finished, you're going to have to upload the Excel just so we get practice of putting things online. We're going to do that for the exam. All right. Go ahead and try and find out which is better, option A or option B. And I'll give you one final hint. They both lose money. All right. Okay, here's the solution. Let me make a couple of important points. As I was walking around, I saw some mistakes that more than one of you were making these mistakes. And so please listen to the following while I address what you need to be able to do. You'll notice that I wrote the full numbers. I typed 0 a couple of extra times. My hand got really tired, but I did it. I put in all the zeros. I'll probably recover. If you don't want to put in all the zeros, then you have to change the title to say like amount in millions. If you're going to just put negative 220 like that, then you need to put amount in millions. Because if you don't, your answer's wrong. It's just $220. So it's your choice. Either make the column title correct or put in all the amounts. But you have to do one or the other. I know that, but you need to put the correct title on the column if it's going to be in millions. Okay, the next thing is, if you didn't draw the cash flow diagram, you probably are at risk of making a mistake. So it's always a good idea to draw the cash flow diagram. So what I mean by that is you should do a little sketch. I gave you the beginning of the cash flow diagram. So take your pencil and draw again when you're going to make the payments. Because if you do that drawing, it will help your spreadsheet to be correct. So you should make from the drawing, you'll see you make a payment and then you get 3 years of revenue. And you want the revenue every year through year 9. And so you're going to have to buy it again in year 3 and then in year 6. But you don't buy it again in year 9. Why is it that you don't spend the $225 million for option B? Why don't we do it again in year 9? It's because if you do it again in year 9, then that means you should be getting more revenue in year 10, 11, 12, and we don't want that. That's outside of our study period. And so you don't do something that's going to extend the cash flow diagram beyond the study period. Okay? So my suggestion is that it's really helpful to make a correct cash flow diagram, do the sketch, and then it'll make your spreadsheet better. A student asked a question. I thought it was a really good question. That is, do you get the same answer if you do the FV analysis versus the PV analysis? So just now, you found out option B is better. Here's the spreadsheet that proves it. Option B is better. Because option B is losing less money. Neither one of them are going to generate a positive profit. That's sometimes the case in public works projects. They don't return money. But we do them anyway because it's in the public interest or it enables some other project to go forward. For these two options, the do nothing alternative is not a choice. If it was, then we'd say do nothing because both of the alternatives have a negative cash flow, a negative future worth. But back to the question of, do you get the same answer? So option B is best according to the future worth analysis. We could do the present worth, and let's try that here just to make sure that we get the same answer. So if we did the present value, here's option A and option B. Okay, if we want to do the present value equals PV of, here's our rate, N, and the amount and we sum it up. Something's not anchored. It's my rate. There we go. So we find the sum of the present values, and then we do it for option B as well, just to make sure that we get the same answer both ways. Here's our rate, and N, and negative of the amount for option B. And I don't like it when it's red like that, so I'm going to change it to currency. And then drag the sum. So option B is better. So here we have the answer in two different ways. We have the answer in terms of present worth analysis or future value analysis. Why would a company want to know it in terms of future value? Maybe it's because the board of this company has a 9-year plan and they want to look at everything in terms of, at the end of that 9 years, what is the value? There's a number of different things that we already talked about on why sometimes you want to do future analysis. So before we move on from this example, do you have any other questions? No, you don't need to do the present worth. I was just showing it as an illustration that you get the same alternative is best regardless of if you do present or future worth analysis. Let me remind you to save your file. I'd like you to upload your file at the end of class to iLearn, so be sure to save it if you haven't already. All right. Does anybody remember GoalSeek? You're going to use GoalSeek today. So let's take a look at in-class exercise 14, problem number 2. You're starting to get to be a little bit of a financial expert. Maybe people in your family know that you're taking cost analysis this semester, so they're coming to you with their financial questions. So in this example, let's imagine that your uncle is making an investment, and your uncle has an 11-year time frame. Option A for your uncle is to spend $250,000 today and then receive $33,000 each year for 11 years. Option B, instead of returning $33,000, option B returns $25,000 each year for 11 years. But the seller hasn't told your uncle yet what will be the price of option B. And so what your uncle wants to know is how much should he pay for option B in order to have it be equal to the total future value of option A. So this one's a little bit more complicated, but I think you can figure it out. To help you along the process, I suggest you do it in 3 steps. First of all, in part A, draw a cash flow diagram. Part B, find the future value of option A. And then in part C is where we use GoalSeek. And let's refresh our memory on how GoalSeek works. GoalSeek asks 3 questions when you start to use it. What are the 3 things GoalSeek wants to know? Okay, which cell to change? All right. It wants to know what is the goal? What is the goal amount? Right. And then finally it wants to know which cell is the goal amount in. In other words, where should it look for the goal amount? Okay, so remember that when you get to part C. I'm going to turn you loose to think that over, but start with a cash flow diagram. That should always be your first reflex, is to do a drawing or a sketch that summarizes the options. Let's take a look at where things are at so far. All right, for problem B, we have to do the same thing where we have our years, and we reverse it for years until year 11. The new interest rate, don't just copy and paste with the same interest rate. That would be a problem if you're using 7. And then here's the cash flow diagram for option A. And we don't yet know how much is going to be paid for option B. So you find the future value of option A, and when you do it, it should be 51,045. And the function that we're using for the future value is the interest rate, the years until year 11, and then negative of the amount. So here's the value of option A. So back to GoalSeek. What does GoalSeek want to know as its inputs? Our goal, it says in the problem statement from the paper, what you should do is make the sum of option A and option B equal. We know what the inflows are. Option B receives $25,000 every year. The question is, how much should he pay? Should your uncle pay $1? No, they're still not equal. Should your uncle pay $2? That's still, they're not equal. We could be here all day if I just typed in the amounts $1 at a time. So instead, we go to Data, What If Analysis, GoalSeek, and our goal is that we want this cell to be equal to 51045.64. That's our goal. And the changing, we want it to change the amount. So we click OK, and it starts playing around with lots of values until it finds the amount that makes these 2 future values equal. So then we say OK, and we have it keep the amount. In the answer, you should put here that, just having a spreadsheet doesn't answer the question. You have to know where is the answer on the spreadsheet. So you can see that I've written these words here. I've said the uncle should pay $181,768 for option B. So be sure to take that last final step and actually answer the question. When we meet on Sunday, we're having an exam. And as I've been walking around, I'm noticing that a lot of you are taking a shortcut that's going to lead to a mistake on the exam. If you're not writing the full amounts, you have to say in the title that it's thousands or millions. So you're setting yourself up for point deductions if you're taking the shortcut. But if you insist on taking the shortcut, please put amount, comma, in thousands, or amount, comma, in millions, if you're not going to type in all of the zeros that should be there. Okay? Okay, guys, we're running out of time, so I want to show one more slide before we end up the class. And that is something called capitalized cost analysis. Capitalized cost basically asks the question, what if you had an investment that lasts forever? What if you put money into the bank and you'll get interest indefinitely? And that's the case in a savings account. Sometimes there are companies that continue to generate revenue forever. So if you can make an investment that doesn't have an end of life, the way that you can find out the value of that investment is the annual series, which is the amount you receive every period, divided by the interest rate. So let me give you an illustration of that. If you withdraw $50,000 each year forever, and it's 10% interest, then how much should you have to deposit today? So what's the present value of an investment that yields $50,000 each year? So according to the formula, the capital cost is going to be $50,000, and we divide that by the interest rate, which is 0.10. So the present value of that is $500,000. So it's quantitatively the same to receive $50,000 a year forever versus $500,000 as a one-time payment. That's just something very brief that we'll revisit again, the idea of capitalized cost, but I wanted to introduce it for you the first time today. Before you leave, you need to submit your in-class exercise on Excel, and also I want to collect the papers. So please put the papers on the chair, but to submit the Excel file, go to our class page on iLearn, and then you'll find this place called In-Class Exercise 14 Upload Location. Upload your file, and I'll take a look at it as I'm going through the grades. All right, so that's it for today. I'll still circulate around for a few more minutes to look at what you did if you've got a question, but I want to remind you, when we get together on Sunday, we're meeting here, and you've got an exam. You're also submitting a homework, so I guess there's a couple things to keep in mind. Yeah, on the chair, as I said. All right. Take care, and I'll see you on Sunday.